All right, we're going to look at how to shift weight on an airplane and then calculate the center of gravity using figures 32 and 33 in your test supplement book. So go ahead and pull that up. You may get a question that's something like this. Refer to figure 32, 33. Upon landing, the front passenger, 180 pounds, departs the airplane. Rear passenger, 204 pounds, moves to the front passenger position. How does this change the CG? And how does it shift? Okay. So what effect does this have on the center of gravity? So we already have the weight. All right. We have the weight of the airplane, the original weight before we shifted anybody. And now we need to figure out how to figure out the moment of each passenger. So we're going to go over here to this graph, and I already have it circled. The front seat arm is 85. But we already have, we can see here there's 180 on here, so we don't have to do any multiplication for the front seat passenger. So we're just going to take that moment of 153 and we're going to subtract it. All right, so go ahead and calculate what that is. Now you're going to do the same thing with the rear passenger. And when you go to your chart, you're going to see that there is no 204 either in the front or the back. So you'll have to calculate the moment using the arm. And the moment is weight times arm. So all you do is 204 times 121. All right. That will give you your moment. All right. So you're going to subtract both of those. 180 times 85 minus 153. You subtract the rear passenger. Now you're going to add the rear passenger back on the airplane, but this time he's in the front station. So the moment is going to be a lot less. And remember, when you multiply 204 times that 85, it's going to give you really big numbers. Just subtract it by, divide it rather by 100. And that'll give you a moment of 173.4 with a reduction factor of 100. All right, so now let's figure out do all the calculations, and we'll come up and we'll see that we have a new weight of 2,510 pounds with a overall moment of 2,033.6 with a reduction factor of 100. Now, how do we find our center of gravity? Center of gravity is always the total moment divided by total weight. All right, divided by 100. So, because in the 100 is because of the reduction factor. So, the old center of gravity is 2,260 divided by 2,690 times 100. All right. And that number will equal 84 if you did your calculations right. So that is the old center of gravity before we did the shift. Now we're going to do the same thing with the new weight and moment. So that's going to be 2,260 divided by, I'm sorry, that's still the old one. backtrack. The new moment is 2033.6 divided by 2,510. Now it's a little bit wonky there, and slide that up. All right. So that will give you a center or a center of gravity of 81. Now, 84 minus 81, very simple math, equals 3 inches. So that means the center of gravity has shifted from 84, which is closer, further back, to 81. The number gets smaller. That means the center of gravity is moving forward. So the center of gravity moved forward 3 inches. Okay, so that is how you can calculate the center of gravity when you remove a passenger and then you shift a passenger from the back to the front.